Now, in this question paper, I better start with multi-correct answer type, or let me just see. My first question must be a clean hit question. Now, 19th question I will start. Rod AB of length 1 meter is fixed at end A at x is equal to 0 and at end B at x is equal to 1 meter is free to oscillate along y-axis. Transverse wave is produced in the rod. Amplitude of oscillation of end B is A. Remember end B. This is a rod of length 1 meter. Right. And at t is equal to 0, the point B is observed to be at a distance of A by 2 from the equilibrium position. The possible equations of the standing wave. My point is, you said length 1 meter and you said it is a rod. Different possible options are there. For example, this is end A and this is end B. One possibility is this. One possibility is this means lambda by 4 is equal to 1 meter. K is 2 pi by lambda. Pi by 2. So therefore, this is allowed. This is allowed. Right. Now, what about 17 pi by 2? Let me just try. Let me just try first of all. So K is 17 pi by 2. 2 pi by lambda. So lambda is 4 by 17. Is this possible? I'll again cross check. I'll again cross check. Is this possible or not? Let me just check. A is sine 17 pi by 2x. Is this possible or not? Let us check. 17 pi by 2 is equal to, actually, one possibility is you may have loops like this. Ramesh, చెప్పు. స్క్రీన్ వేరే వస్తుందా? ఇక్కడ కరెంటు పోయినట్టుంది. కదలటం లేదా ఇప్పుడు? సరే, నేనే రికార్డ్ చేసేసి అది పెడతానని చెప్పు వాళ్ళకి, ఇంక వదిలేసి. రైట్ రైట్, ఓకే. ఇక్కడ కరెంటు పోయింది. మామూలు పంపించే. ఎవరు తీసుకుంటున్నారు క్లాసు? కానీ స్క్రీన్ షాట్ స్టక్ అయిపోయిందని చెప్తున్నావుగా. వచ్చినా ఈ బేసిక్ వే వస్తాయి, మళ్ళీ పోతే ఇంకొకసారి ట్రై చేస్తాను. ఇప్పుడు స్క్రీన్ కనిపిస్తుందా? కదులుతుందా? అప్ అండ్ డౌన్ కదులుతుందా? రైట్ రైట్, ఓకే. రైట్, ఓకే. Now the question is, students, in this part, whether 17 pi by 2 accepted or not, that we will work. 17 pi by 2 is 2 pi by lambda. Pi cancel. Lambda is 2 by 17. This is where I am worried. Like, how is this possible? Suppose n loops plus a half lambda is the full length 1 meter. So lambda can be written as 2 by 2n plus 1. What if n becomes 8, which means if there are 8 loops, then what happens? This will become 2 by 17. So which means this is also possible. I mean these loops are possible. Okay. So that's fine. Next. Yeah, the possible equation of the standing waves. The amplitude of the oscillation of the end B is at A, at T is equal. First of all these things are confirmed. Amplitude part is okay for me. Possibilities are there. This is done. The only thing that you need to check is T is equal to 0, what is happening? At t is equal to 0, what is happening? At t is equal, no, at t is equal to 0, cos minus pi by 3. Now, if you take this, put t is equal to 0, cos minus pi by 3 is nothing but cos 60. So, amplitude by half. Clear. Now, I'll take this. Put t is equal to 0, sin 7 pi by 6. 7 pi by 6 is pi plus pi by 6. Pi plus pi by 6. All silver teacup. So you'll get sine pi plus something. You'll get sine 30 again. Amplitude may half. You'll get A by 2. It did not mention above or below actually. If it is minus A by 2 plus A by 2, I am confused. But it didn't mention something like that. So therefore, I will go with this. No issues. Same thing happens in this case also. Same thing happens in this case also. Trust me. Because you said possible equations. With this information, I can say A, B, C, D are possible. If you give me further information, like for example, if it is moving upwards or it is moving downwards, in that case, I can filter few of the equations. But such a sufficient information was not given by you. Therefore, I will go with A, B, C, D as my options. 20. A standing wave is set up in a string fixed at both the ends. Then the sum of total energy per unit length at nodes and antinodes is constant. True. So you said total energy, not KE or PE. Suppose if you said KE, at nodes it is 0. At antinodes it keeps changing. Similarly, if you ask me PE, at nodes, sometimes it is maximum, sometimes it is 0. But you asked about the total energy. So therefore, it is a total energy, so it is okay. The total energy of a midway point between a node and adjacent node is a constant. A total energy of a point midway between a node and adjacent node. That is okay, fine. Why? You are speaking about this. A total energy of a point midway between a node and adjacent node is constant. I don't agree with this because if you take only this point potential energy is 0 and kinetic energy is 0. Only this point. Speak about this point. So I don't agree with this. If the string has a standing wave and a component of traveling wave, then the kinetic energy of the points of minimum amplitude is true. I told you already. At that instant, nodes won't have zero displacement. Nodes will have some displacement. I told you this. We have done some 5 by something based answer in our assignment also. Right. So therefore, that is okay. Fine. Next, if the string has a standing wave and a component of traveling wave, then the potential energy of the points of maximum amplitude is a non-zero at some instant of time. True. True. But remember, only under ideal conditions only the potential energy is 0 here, which means node is perfect zero displacement, anti-node is the maximum displacement. So I agree with 20 question. The key what they have given is actually ABCD. I suggest ACD as my answer. Right. Now, 21st question. Strings AB and BC of length 1 meter and 0.5 meter respectively are joined together at end B as shown. Point B is the junction of the two strings. The mass per unit length of string AB and BC were given respectively. Tension is also given respectively. Fine. See, first, before reading the question, let me understand what is V1. V1 is root T by mu1. Root of 100 by mu1 means 0.16. Remember, this will become 25 meter per second. Similarly, V2. V2 is root T by mu2, which is nothing but 100 by 0.25. This will become 20 meter per second. I have clear information about velocities. A sinusoidal wave pulse of amplitude 2 meter is produced at end A, partly reflected, partly transmitted, joint B. You know, amplitude ratio of amplitude of transmitted by amplitude. Okay, 1 minute. Amplitude of the reflected wave. Amplitude of the reflected wave is V2 minus V1 by V2 plus V1 times amplitude of the incident wave. Amplitude of the transmitted wave is simply 2V2 by V2 plus V1 times amplitude of the incident. Now you go for the ratio. AR by AT. You'll get V2 minus V1 by 2V2. Substituting, what you will get, V2 minus V1 is, you are picking up the magnitude only here. 5 by 2V2, 40. This is 1 is to 8. You asked transmitted by reflected, 8 is to 1. Correct answer. You can comfortably do this, provided if you know the formula for this. Next, a transmitted wave in a string of linear mass density mu1 is incident on the junction at point J. The intensities of the reflected and transmitted waves both as a function of mu2 by mu1 are plotted. The correct sketch is, what is taken here? Mu2 by mu1, right? Okay, right. Options given. What is the difference between A and B? Yes, I got it. It is intensity of transmitted wave. This is intensity of the reflected wave. Intensity of transmitted wave is proportional to A transmitted square, which is again proportional to 2V2 by V1 plus V2 square. So AT square proportional to, or this you can write as V1 by V2, which is root mu2 by mu1 plus 1 whole square. Now you speak, which graph refers that? Yes, you, yes, you increase mu2 by mu1. What happens? IT will reach root mu2 by mu1. Similarly, you take I reflected. I reflected is proportional to IR square, which is proportional to modulus of V2 minus V1 by V2 plus V1, proportional to root mu1 by mu2 minus 1 by mu1 by mu2 plus 1 square. Accordingly, you need to decide. When mu2 by mu1 is equal to 1, for example, what happens? Or mu2 by mu1 is equal to 0. See, the intensities of reflected and transmitted wave both as a function of mu2 by mu1. Which means if you increase mu2 by, I think I'll just speak in different way. If you permit me, ఇఫ్ యూ పర్మిట్ మీ ఐ విల్ థింక్ ఇన్ ఏ డిఫరెంట్ వే. అంటే ఇక్కడ చాలా సెన్సిబుల్గా ఆలోచించాలి. ఇప్పుడు ఫర్ ఎగ్జాంపుల్ పర్ఫెక్ట్ రిఫ్లెక్టర్ అనుకోండి. ఇఫ్ పర్ఫెక్ట్ రిఫ్లెక్టెడ్, నో ట్రాన్స్మిషన్ టేక్స్ ప్లేస్. అంటే మ్యూ2 ఇన్ఫైనైట్ కావాలి. అప్పుడు మ్యూ2 ఇన్ఫైనైట్ వెరీ లాంగ్ అయినప్పుడు మీరు చూసినట్లయితే ఐ ట్రాన్స్మిటెడ్ 0 అయింది. కాబట్టి ఇది రాంగ్ గ్రాఫ్. ఇది రాంగ్ గ్రాఫ్. ఇది రాంగ్ గ్రాఫ్. సో ఐ హావ్ ఫిల్టర్డ్ 2 graphs. నా ఆన్సర్ లైస్ బిట్వీన్ డి అండ్ డి. ఓకే, ఇది పర్ఫెక్ట్ రిఫ్లెక్టర్ అయితే, ఒకవేళ ఇది పర్ఫెక్ట్ ట్రాన్స్మిటర్ అనుకోండి, దేర్ వోంట్ బి ఎనీ రిఫ్లెక్టెడ్ వేవ్. పర్ఫెక్ట్ ట్రాన్స్మిటర్ వేవ్ తీసుకున్నారు అనుకోండి, అంటే మ్యూ2 0. అంటే అప్పుడు ఇక్కడ ఉండేది మ్యూ2 0 తీసుకున్నట్లయితే అసలు ఫస్ట్ ఆఫ్ ఆల్ రైట్ సైడ్ వెళ్ళేదే ఉండదు, మొత్తం అంతా వెనక్కి వచ్చేస్తుంది కదా. పర్ఫెక్ట్, ఇది ఒక ఫ్రీ వైర్ లాంటిది అనుకోండి ఫర్ ఎగ్జాంపుల్. ఏమవుతుంది ఇప్పుడు, టోటల్ వేవ్ ఏదైతే ఉంటుందో ఆల్మోస్ట్ ఏం జరుగుతుంది అక్కడ, టోటల్ వేవ్ 100% రిఫ్లెక్ట్ అయిపోతుంది ఆ కేసులో. అసలు ఇంకా రైట్ సైడ్ ఏమి వెళ్ళదు కాబట్టి లెఫ్ట్ సైడ్ కంప్లీట్ వితౌట్ ఎనీ డిమినిషింగ్ యాంప్లిట్యూడ్ వచ్చేస్తుంది. సో 100% యాంప్లిట్యూడ్ ఇక్కడ రిప్రజెంట్ చేశారు. ఇంకో గ్రాఫ్ చూద్దాం మనం. ఇది 100% రిప్రజెంట్ చేయలే, రాంగ్. సో ఐఎమ్ టీచింగ్ యూ అగైన్. అరియర్ నేను ఇక్కడ తెలివిగా ఈ ఫార్ములా అప్లై చేస్తే వర్కౌట్ కాదు. ఐ షుడ్ నాట్ అప్లై దీస్ ఫార్ములాస్. I should apply ideal conditions. What happens when mu2 by mu1 becomes infinite? What happens when mu2 by mu1 becomes 0? When mu2 by mu1 becomes 0, infinite means this is a perfect reflector. So there is no transmission. If mu2 by mu1 becomes 0, what happens is, it is like maximum wave reflects as it is without any diminution. So this is how you should take. So our condition is satisfied చేసేది only B. So I should go with B. Right. 23. Mark out the incorrect statements with respect to the wave speed and particle velocity for a transverse traveling wave on a string. Next, wave depends upon the properties of medium and on the properties of the wave. Are there incorrect statements you want? V root T by mu. The wave speed is same for the entire wave, while particle velocity is different at different right, because particle velocity depends on two things: velocity of the wave plus slope at that point. Different points have different slopes. So the wave speed is same for the entire wave is correct statement. This is a correct statement, but you want incorrect statement. Wave speed depends upon property of medium, but not on the wave properties. Correct. Because whether it is a sine wave or a cos wave or whatever it is, triangular wave, V is root T by mu. We have already done this. V is equal to root T by mu is what we will use. Whether it is a triangular wave, square wave, whatever the nature of the wave, we will use this formula, right? Particle velocity depends on properties of the wave and not on medium properties. Particle velocity depends on properties of the wave and not on medium properties. Actually, it depends on V, which means this is correct, and not on medium properties. I'm still finding some confusion in it. One thing I can say, this is single correct answer type. So what I can say is, confidently I can say option C. Whatever you see here, option C is undoubtedly wrong, but option D and option A represent the same statements actually. Okay, we'll go with C when we are confident about that. Next, 25. 25 is again an easy question. String of length L is fixed at both the ends and is vibrating in second harmonic. The amplitude at nodes, antinodes is 2 mm, and amplitude of a particle at a distance L by 8 from fixed end. You said second harmonic, two loops. Y is equal to A sin kx cos omega t. This is the amplitude part, right? And you said length is L, lambda is L. So 2 pi by lambda is nothing but 2 pi by L. So Y amplitude part, if you take, it is A sine 2 pi by L times x L by 8. A sine pi by 4. A by root 2. So A by root 2 is my answer. So A by root 2 mm. A is nothing but the amplitude part, 2 mm. Right. Absolutely correct. Next. A block having mass m 8 kg is suspended from a support through a string having linear mass density so and so. Find the speed with which the speed a wave pulse can be produced at the bottom of the string if the point of support moves with an acceleration of so and so. Right, no issues. Block having mass 8 kg suspended from a support through a string. Okay, find the speed with respect to the string. With which speed a wave pulse can proceed at the bottom of the string if the point of support moves with an acceleration. Point of support moves with an acceleration అన్నావు కదా, అప్పుడు స్ట్రింగ్ ఇలా ఉంటుందండి. ఇది ఎం 1 minute. There are different accelerations here. Components తీసుకోండి. 8m is one component. 4m is another component. mg is another component. Above all, string makes some angle theta. Okay. Don't get any confusion. See here this is a 32. 8 fours. 8 8. This is a 64. This is 80. So finally, this particular point is having 64 Newton force in this direction and 80 minus 32, 48 Newton in this direction. The resultant is 64 array 16 fours, 16 threes. So 16 fives, 80 Newton. And that's the tension over here. Fine. You want the speed of the V is equal to root T by mu. It is more of mechanics question. Now tension ఎంత ఉంది 80. Mass per unit length ఎంత ఇచ్చారు 20 into 10 power minus 4. 4 times 2 into 10 power 2. 200 meters per second. In 200 meters per second. Right. అంతే కదా. Right. It is 200 meters per second. మరి తేడా ఏదో ఉంది చూడండి, ఇక్కడ సెంటీమీటర్స్ పర్ సెకండ్లో అడుగుతున్నాడు, ఇంకా ఎక్కువ వచ్చేస్తుంది అది. ఇప్పుడు ఈ 10 power 4 it goes up. I think you will get a bonus for this. Why? Because 200 meters per second is the answer here, undoubtedly. But they have asked you centimeters per second. So in that case, it will become 2 into 10 power 4 meters per second, where you cannot mark, I think so. You cannot mark, I think so. Right. Next. What all possible cases that we will work right now? 27. An ant with mass m is standing peacefully on the top of a horizontal stretched rope. The rope has ఎంతో కొంత tension somewhere. Without warning, a student starts a sine wave lambda propagating along the motion of the rope is in a vertical. The minimum wave amplitude with which the ant feel weightlessness momentarily. When will it feel weightlessness? If, for example, there are two possible cases. The maximum amplitude of the string is omega square A. Suppose if it moves downwards with this acceleration, so the ant will experience a pseudo force Ma max and weight force and normal reaction force. When is normal reaction? 0. When Ma max is mg. So A max is g, means omega square A is g. That's the T. So omega square A is omega square A is g. Here some data is required for us. So A minimum required is g by omega square. G by omega can be written as anything given about the velocity of the wave? No. Can you please help me in writing velocity of the wave? Root F by mu. Root 3.125 by 0.1. That is V. Lambda is also given. So omega square can be written as V square K square. 4 pi square by lambda square. You substitute, you will get the answer. Here they are expecting G square to be taken as pi square. అందుకని ఆ 3.125ని పైలోకి మార్చేసేయండి మీరు. రూట్ 3.125ని రూట్ పైగా చేసుకోండి. రైట్. సో దట్స్ ఇట్. You just substitute, they wish to cancel these two. What you will have finally is lambda square by 4V square. Substitute just you will get the answer. Very simple question. It is not waves. It belongs to mechanics question. 28. Figure shows a rectangular pulse and a triangular pulse approaching each other on a string. The speed of each pulse 0.5, right? The displacement of the particle at x is equal to 1 centimeter at 2 seconds. See, at 2 seconds, what is going to be the picture? At 2 seconds, it moves by 1 meter. Let me write all this. 0, 1, 2, 3. -1, -2. See, speed is 0.5 and you are asking at 2. Means it will move by 1 centimeter. So, triangle 1, 2, 3, 0. Triangle, hello boss. Triangle, I'll represent like this. Next. This will also move by 1. 0 will reach 0, -1, 2. It will reach with a different color again. Superposition happening. Amplitudes gets added. So 2 plus 2 gives 4. Answer is 4. So therefore, this is the superposition zone. Right. Easy question actually. Only thing is you need to focus the given data. Aluminum wire of length given, cross section given, connected to a steel wire of cross section, area and having length same cross section, length 0.8. This is already H.C. Verma model, which we have done in my class. The number of nodes, joint is a node. Very simple. So I am representing one color, aluminum, the other color with what you call steel wire. There are N1 loops here, the N2 loops here. So what I know is N1 lambda 1 by 2 is 0.6. N2 lambda 2 by 2 is 0.8. Now you take N1 by N2, lambda 1 by lambda 2, 3 by 4. Hold on. N1 by frequency is the same. So lambda 1 by lambda 2 it depends on V1 by V2. Tension is the same. So root mu 2 by mu 1 is 3 by 4. Hold on. N1 by N2. Mu 2 means density into cross section. Mu 2, the other wire, steel wire density 5200 into cross section anyway same, no issues. A mu 1 1300 into A. This is 3 by 4. Finally, 4 is to 1 under root 2 is to 1. So N1 by N2 is 3 by 8, which means left side 3 loops, right side 8 loops is the minimum loops. మీకు ఆల్రెడీ చెప్పాను, if there are 11 loops, there will be 11 antinodes, and how many nodes? 12 nodes. What is that they are asking? The number of nodes, excluding the 2 at the ends of the wire in oscillation of the wire in the lowest frequency for which the joint of wire is a node, is 5x. Find x is what they are asking. 1 minute, let me 3 is to 8. Yes, 3 loops left side, 8 loops right side. So total how many? 11 loops. 11 loops means 12 nodes. 12 nodes. 12 nodes means leftmost, rightmost, they want to exclude. So 10 nodes. So 5 into 2, 10 nodes. So answer is 2. Right. Easy question only. Nothing to skip in this. Next. Right. A transverse harmonic wave is propagating along a taut string. Tension in the string is 50 newtons. Linear mass density given. String is driven by 80 Hz oscillator tied to one end. Amplitude 1 mm. The other end of the string is terminated so that the wave energy is absorbed and there is no reflection. Right. Average energy of the wave on a 1 meter long segment of the string is E. Take pi so and so. The nearest integer of 2E is. What is that they are asking? Transverse. First of all, what is velocity? Root T by mu. Root T by mu 50 by 0.02. This you can write as 25 into 100. 50 meter per second. Right. Lambda. Lambda is 50 by 80. 5 by 8. But what length you have taken? Nothing mentioned. Amplitude is what I know. The other end of the string is terminated. 1 meter long segment of the string is E. Right? No issues. They are asking average energy of the wave. Average energy is what they are asking. Normally, T dou y by dou x square corresponds to energy at a point. Like for example, is a progressive wave. For example, A sin kx minus omega t, for example. T into AK cos kx minus omega t square. Right. Per unit length is this. Into dx 0 to 1. This is what you need to do. After doing which, you will get the proper answer. So what they will, this is given as E. They want 2 times of this. You need to solve only this part. That's all. There is nothing else to do. And remember, you take t is equal to 0. No issues. Because one thing you need to take as constant. So at t is equal to 0, 0 to 1, t, a square, k square, cos square x dx. This is what you need to do. And equate that to E. 2 times of that is your answer. It's a simple question, no issues. Paragraph type. This is a direct previous IIT question. Answer the following by appropriately matching the list based on the information given in the paragraph. Musical instrument is made used for 4 different metal strings, 1, 2, 3, and 4, with mass per unit length mu, 2 mu, 3 mu, 4 mu, respectively. The instrument is played by vibrating the strings by varying the free length in between the range L0 and 2L0, and length of the string can be modified from L0 to 2L0. It is found that in string 1, yet free length lambda naught, tension T naught, fundamental frequency is F naught. ఒక్క నిమిషం ఆగండి. I'll write F naught as 1 by 2L root T naught by mu. Wherever I have F naught, the general meaning is this. Right. Okay. Okay, hold on. List 1 gives the above 4 strings. List 2 gives the magnitude of some quantity. If the tension in each string is T naught, the correct matching for highest fundamental frequency in F naught units. అంటే right side in the multiples of F naught అని అర్థం. ఇప్పుడు ఫర్ ఎగ్జాంపుల్ స్ట్రింగ్ 1లో హైయెస్ట్ ఫండమెంటల్ ఫ్రీక్వెన్సీ ఏమవుతుంది? F naught అవుతుంది. అంటే 1కి పిఏ మ్యాచింగ్. 1కి పి మ్యాచింగ్ రెండిటిల్లో ఉన్నాయి. జస్ట్ క్యాన్సిల్ దిస్. స్ట్రింగ్ టు 2 mu. ఓకే, హోల్డ్ ఆన్. స్ట్రింగ్ టు 2 mu. ఫర్ స్ట్రింగ్ టు 2L0 into T naught by 2 mu. This is nothing but F naught by root 2. 1 by root 2. This is for string 2. సో అదేమొచ్చింది? ఆర్తో మ్యాచింగ్ ఉంది. 2R పోయింది. చూడండి, జస్ట్ చెక్కింగ్ 2, you are getting the answer. First part fundamental, second part F naught by root 2. Right. So 31st question is done. Next, 32. A triangular wave pulse on a string is moving in the positive x direction with a speed v. Tension in the string is F, linear mass T is equal to 0. The shape of the pulse is given as minus x less than minus L, nothing. Minus L less than x less than 0. It is like y is equal to h by L times L plus x, or I can write it as h plus h by Lx. Right. So you'll put here x as put x as minus L, it is 0. Put x as 0, it is h. Right. I got a clear point now. This is my wave pulse. This is of height h. అయిపోయిందిరా. దట్స్ ఆల్. స్లోప్ ఇప్పుడు ఇక్కడ మీరు ఒక్కొక్క ఆప్షన్ చూసుకోండి. ఏ తీసుకోండి. మైనస్ ఇన్ఫినిటీ టు ఎక్స్ లెస్ దాన్ ఆర్ ఈక్వల్ టు ఎట్ ఈజ్ ఈక్వల్ టు 0 ఇక్కడ ఉందండి. నాకు దీనికి సంబంధం లేదు. అయిపోయింది. రైట్. పుట్ టీ ఈజ్ ఈక్వల్ టు 0. Minus infinity to the less than x less than Vt minus L. And you are speaking somewhere in this zone. In this zone, there is no string. There is no disturbance. Slope is 0. So therefore, for A, P is the correct answer. Next. Now, as Vt minus L less than or equal to x less than or equal to Vt. అసలు ఫస్ట్ ఏకి పి మ్యాచ్ అయ్యేవి రెండే. ఈ రెండు తీసేయండి. టీ చెక్ చేయటం వల్ల యూజ్ లేదు. పి ఒకటి చెక్ చేయాలి. రైట్. Vt minus L less than or equal to X less than or equal to Vt. Put T is equal to 0. Minus L less than or equal to X less than or equal to 0 means this zone. This zone. Okay. Understood. Instantaneous power transmitted is non-zero. Correct. Power formula tension into dou y by dou x into velocity of the particle. So all are non-zero in this. So therefore, V key Q is correct. Next, one more important point. Slope is positive. Wave is traveling in the forward direction. Slope positive. Wave particle velocity is negative. So therefore, particle velocity is negative in this zone. In this zone. In this zone. So, కాబట్టి QS correct. Correct. QR wrong. That only with the two checkups I have completed the question. Next. In a standing wave is setup. అసలు ఈ క్వశ్చన్ లో వేవ్ ఫామ్ రాసుకోవటమే స్కిల్. In a string, a standing wave is set up whose equation is given by y is equal to a sin kx cos omega t. Mass per unit length of the string is mu. Next question. At t is equal to 0. T is equal to 0. At t is equal to 0, it is of this form. నేను ఆల్రెడీ ఇది అలవాటు చేశాను మీకు. ఏ సైన్ కేఎక్స్ కాస్ ఒమేగా టీ ఈజ్ ఈక్వల్ టు 0 ఫామ్ ఇట్లా ఉంటుంది. రైట్. మీకు ఏం కావాలి? ఎట్ టీ ఈజ్ ఈక్వల్ టు 0. రైట్. బీని చెక్ చేస్తే పోద్దాం అసలు. ఇది టీ ఈజ్ ఈక్వల్ టు 0. ఈ ఫామ్ ఏంటి? T/8 కూడా అడిగాడు. రైట్. T/8 అంటే 45 degrees. ఇంకొంచెం పెద్దది గీస్తాడు. This is T is equal to 0. T is equal to T/8. T/4. This is T/2. Right. రైట్. అరే నేనేమనుకుంటున్నానంటే ఐ విల్ చెక్ బి ఆప్షన్. బి ఆప్షన్ ఎట్ T/8. At T/8. The total energy per unit length at x is equal to 0. What is x is equal to 0? Node. Remember, this is the maximum energy. But at t is equal to T/8, slope is not maximum. కాబట్టి P కరెక్ట్ కాదు. రైట్. షూర్. P తీసేసేయండి. సో కాబట్టి Pకి P ఉన్న మ్యాచింగ్ ఏది తీసుకోవద్దు. కాబట్టి క్యాన్సిల్. నెక్స్ట్. ఆర్ టోటల్ ఎనర్జీ పర్ యూనిట్ లెంగ్త్ at x is equal to lambda. x is equal to lambda. నో. అట్ దట్ ఇన్స్టెంట్ అదర్ ఎండ్ కూడా, అంటే మీరు ఉద్దేశం మమ్మల్ని కన్ఫ్యూజ్ చేయడానికే ఇది x is equal to λ/2 అయితే ఒకసారి చూడండి. అదర్ లూప్లో ఇలా కదా ఉండేది ఫార్మాట్. అది కూడా ఫుల్ స్లోప్ కాదు కదా. ఈవెన్ ఎట్ దిస్ పాయింట్ ఆల్సో ఇట్ ఈస్ నాట్ మ్యాక్సిమం స్లోప్, మినిమం స్లోప్. కాబట్టి యూ షుడ్ నాట్ యాక్సెప్ట్ క్యూ. రైట్. టీ యాక్సెప్ట్ కాదు, క్యూ యాక్సెప్టెడ్ కాదు. నెక్స్ట్ ఆర్. ఆర్ అరే క్యూ యాక్సెప్టెడ్ కాదంటే ఆర్ కూడా అంతే సిచ్యువేషన్. నెక్స్ట్ ఎస్. Power transmitted through the point x is equal to lambda is 0. Always it is correct. Because the velocity of that particle is always 0. Power transmitted through node is 0. So, కాబట్టి at x is equal to lambda is a node. So, power transmitted through that point is 0. Correct. Power transmitted through the point x is equal to lambda by 4. This is lambda by 4. Okay. అరే ఈ పాయింట్ కూడా స్లోప్ ఎప్పుడు జీరోనేగా. Even for this point is also slope 0. Not only node as well as at antinode point. Because at node velocity is 0, no power transmitted. Because at antinode slope is 0, no power is transmitted. Why? Because I have mentioned the formula clearly. Slope and velocity of the particle, both are involved. So therefore, ST is a correct option. No other option is bearing such condition. So therefore, with only one point, I have concluded the question. అలా మీరు ఎత్తుక్కోవాలి క్వశ్చన్లో. నెక్స్ట్. String of length lambda is fastened between the two supports as shown in the figure. End of the string can be made free or fixed at x is equal to 0 and x is equal to L. A traveling wave so and so is generated at x is equal to 0. It gets reflected from the other end. The reflected wave is given by a sin kx plus omega t plus phi. The two waves superposed to form standing waves so that at a point, this is the symbols of meaning. అరే ఇది మనం చెప్పేది ఏంట్రా, ఫ్రీ బౌండరీ అయితే రిఫ్లెక్టెడ్ వేవ్ అండ్ ఇన్సిడెంట్ వేవ్ సేమ్ ఫేజ్, పై ఈజ్ ఈక్వల్ టు 0 అవుతుంది. రిజిడ్ బౌండరీ అయితే రిఫ్లెక్టెడ్ వేవ్, ఇన్సిడెంట్ వేవ్ విల్ హ్యావ్ ఎ ఫేజ్ డిఫరెన్స్ ఆఫ్ పై. నో ఇప్పుడు క్వశ్చన్, బౌండరీ ఈజ్ ఫ్రీ at x is equal to 0, fixed at x is equal to L. Obviously P will match for that. Right. Next. పి మ్యాచింగ్తో ఉన్నది ఇది ఒకటే, కాబట్టి ఇది ఏది కాదు అసలు, అయిపోయింది. ఇలా కూడా చూడనక్కల్లా, కానీ మనం చెక్ చేసుకెళ్దాం ఒకసారి. అండ్ ఇదేంటి కే, అవును కే ఎలా చెప్తారు మీరు, ఎన్ని ఇప్పుడు ఇదేమన్నారు, బౌండరీ ఈజ్ ఫ్రీ అట్ ఎక్స్ అంటే n+1/2 లూప్స్ కదా ఇప్పుడు వచ్చేది. n+1/2 loops times lambda by 2 is a length. n+1/2 loops, ఒక లూప్ lambda by 2, lambda 2pi by lambda అని k అని అనుకుంటే, lambda ని 2pi by k అంటే pi by k is L. So therefore k is 2n+1 pi by L. 2n+1 pi by L. n is an integer. మరి s వర్కౌట్ కావటం లేదే. ఐ రిపీట్ అగైన్, ఇలా రావాలి ఫార్మాట్. అది అంటే ఇవి n లూప్స్, ఇది హాఫ్ లూప్. n లూప్స్ లెంగ్త్ lambda by 2, lambda by 4. ఇది లెంగ్త్ ఆఫ్ ద స్ట్రింగ్ కావాలి. 2n+1/4 lambda L కావాలి. lambda అంటే 1 minute. దీని నుంచి 2n+1/4L 1/λ కావాలి. k అంటే 2pi by lambda. 1/λ is nothing but k by 2pi. k వచ్చేసేటప్పటికే 2n+1/2L times pi. ఓకే, నో ఇష్యూస్. నేను n is equal to 0 ఎగ్జిస్ట్ అవుతుందో అనుకోవటంలో వాడు n is equal to 0 కన్సిడర్ చేస్తున్నాడు. అంటే ఈ కేసు కూడా కన్సిడర్ చేస్తాడు వాడు. నా దానిలో n is equal to 0 పెడితే ఈ కేసు అవుతుంది, వాడి దానిలో n is equal to 0 ఉండదు. నో ఇష్యూ, ఎస్ ఈజ్ అలౌడ్. Correct. Right. So what time I have started the paper? Literally, I have started at 3:45. Now the time is 4:40. So how many questions I have left? I have left the 18th question. Left the 18th question. Left the 24th question. Rest all I have done. In fact, I still have 5 more minutes of time, excluding the disturbances in between. So in this paper, you can comfortably do. See, when you have such a question, ignore this. It is a lengthy question. Ignore this. No issues. But this question can be done. Sonometer string AB of length 1 meter is stretched by a load and the tension T is adjusted so that the string resonates to a fundamental frequency of 1 kilohertz. Any point P of the wire may be held fixed by use of movable bridge that can slide along the base of the sonometer. Correct the incorrect statements కావాలి మీకు. If the point P is fixed so that AP PB 1:4, the smallest frequency for which the sonometer wire resonates is 5 kilohertz. Let me just see. Fundamental frequency అంటే దాని అర్థం F0 is equal to 1/2L root T by mu. ఇప్పుడు మీరు లెంగ్త్ 1:4 పార్ట్స్ చేస్తున్నారు అంటే ఇది L/5 పార్ట్స్, ఇది 4L/5 పార్ట్స్. ఇప్పుడు దీనిలో ఫండమెంటల్ అంటే F is 1/2L/5 times root T by mu, which is 5F0. So therefore 1 kilohertz అయితే F0, 5 kilohertz అంటే 5 hertz. This is a correct statement. If PB taken at midpoint of AB and a fixed, then when the wire vibrates in the third harmonic of its fundamental, the number of notes in the wire, including A and will be totally 7. Hold on. You said you placed it in the mid point. ఇక్కడ మిడ్ పాయింట్ లో ప్లే చేశారు అండ్ వైర్ వైబ్రేట్స్ ఇన్ థర్డ్ హార్మోనిక్. ఇక్కడ 3 లూప్స్, ఇక్కడ 3 లూప్స్, 6 లూప్స్ అయితే 7 నోట్స్ వస్తాయి, 6 యాంటీ నోట్స్ వస్తాయి. కాబట్టి దిస్ ఈజ్ ఆల్సో కరెక్ట్. రిమెంబర్ వెన్ ఐఎమ్ సెయింగ్ 7 notes including this and this. If the fixed point P divides AB in the ratio 1:T, then the tension need to make the string vibrate at 1 kilohertz will be 3T, neglecting the terminal effects. I'll check once. D. The fundamental frequency of the sonometer wire when P divides AB in the ratio A:B will be same as the fundamental. True. అరే ఇప్పుడు ఇది ఏ పార్ట్, ఇది బి పార్ట్ అయినా, ఇది బి పార్ట్, ఇది ఏ పార్ట్ అయినా ఓకే, నో ఇష్యూస్. ఫర్ ఎగ్జాంపుల్ ఇక్కడ N1 లూప్స్, ఇక్కడ N2 లూప్స్ లో వస్తుంది. అప్పుడు ఇక్కడ N2 లూప్స్, ఇక్కడ N1 లూప్స్ తో వైబ్రేట్ అవుతుంది సెకండ్ కేసులో, నో ఇష్యూస్. దిస్ ఈస్ ఎ కరెక్ట్ స్టేట్. Frankly speaking, one must be incorrect statement, so C is incorrect. But otherwise also I'll verify. If the fixed point P divides AB in the ratio 1:2, 1:2, right? Tension needed to make string vibrate at 1 kilohertz will be 1:2 అంటే ఇక్కడ 1/3 పార్ట్ 2/3 పార్ట్స్ అయింది లెంగ్త్. L/3 2L/3 అయింది. అప్పుడు ఫ్రీక్వెన్సీ వచ్చేసి 3 times 1/2L root T by mu. ఇప్పుడు ఇది T dash, ఇది 1/2L root T by mu కావాలి అంటే, సేమ్ కావాలి అంటే కండిషన్ ఏంటి? ఈ ఈక్వేషన్స్ నుంచి 9T dash is T. T dash 1/9 times T. బట్ నువ్వు ఏమన్నావు? 3T అన్నావు. రాంగ్. దట్ ఈస్ అ రాంగ్ స్టేట్మెంట్. యూ వాంట్ ఇన్కరెక్ట్ స్టేట్మెంట్. See, I have completed the entire paper. Now it is 444. Except this, I have done all, which means you can try this. You can try this. Even you go wrong, no issues. Not even you mark 2, no issues. Next, you can try this. 8 plus 3, 11 marks. 11 marks. You can try this. 14 marks. 14 marks. You can comfortably try this. 17 marks. 17 marks. You can try this. 20 marks. You can comfortably try this. 23 marks. You can try all four. 21 plus 12. 33 marks can be scored comfortably in this paper. Those who are attending regularly, they can score 33 marks comfortably. I'll see your marks tomorrow while I am interacting with you personal. Right.